So 13.3 is about the fundamental theorem of algebra, which you've probably done a little bit of before, so it won't be too big of a deal. Interestingly enough, it was something that was published a long time ago by Gauss. He was the one who, as a child, I think I told you the story, like did his dad's taxes correctly for him when he was like 7 or 6 because he made mistakes, and he was just a child prodigy all around. By the time he was a teenager, he had published a book already and had his doctorate in math, and pretty big deal. But anyway, back then, this one of the texts contained this theorem that's attributed to him, and it looks something like this. If a to the n, x to the n, plus a sub n minus 1, x to the n minus 1, plus etc., plus a1x plus a0 equals 0. This is what we call a polynomial. Well, not when he was 6 or 7, but yeah. The degree starts with n, and then the exponent for x just goes down like it always does. So if it's quartic, it goes x to the 4, x to the third, x to the second, x to the first, until there's no x.
Is that A1?
This is A1, yes. Okay. All you have to know, you guys, is that these are just coefficients. And these coefficients can be any complex number. Okay. And then these exponents have to be integers, positive integers. Like all the ones we've been dealing with. Cubics, quartics, no crazy exponents like x to the 1.7 or x to the root 6. It'll always be nice polynomials. So the fundamental theorem said that a polynomial like this one has at least one root in the complex number system. And now if you include multiplicity, then a degree n polynomial, and I think it was Colleen who asked about this a day or two ago, a cubic you would expect would have how many roots? 3. A quartic would have 4. So if a degree n polynomial is what we're looking at, we would expect it to have how many roots? N roots. This is if you count multiplicity, meaning repeated roots. Obviously, you can't go over that amount, but you could certainly have less. Okay, so here's an example to illustrate this point. If you have x cubed plus 3x squared plus 3x plus 1 equal to 0, you don't have to know so much about how to factor this, but I'm just illustrating a point. This will factor to x plus 1 to the third power. What's the root here? Negative 1. Okay. But what's the multiplicity? Okay. So in other words, negative 1 gets counted 3 times. Because it would show up as x plus 1 times x plus 1 times x plus 1. Okay, does that kind of make sense? You're never going to have over 3 roots, but you're always going to have at least 1. And that's pretty much it. As long as you have a polynomial, this will always be the case. Questions on that? Okay. Which of the following has at least 1 root? So I'll just give you a few different equations or functions, and you tell me if you think they have at least 1 root, or is guaranteed to have at least 1 root or not. Well, that's precisely what I said. So we got 3 different functions here. Let's call them 1, 2, and 3. Over root 3 over x to the root 7. The only thing that we need to guarantee at least 1 root is for these functions to be what? Look at what we wrote down for the fundamental theorem. Yes? So let's look at this first one. Do we have positive integer exponents? And do we have numbers that are complex numbers as coefficients? So 1, and we just call that a polynomial. Okay, so we're going to say 1 does, because it's a polynomial. What about 2? Complex coefficients? What about the exponents for x? 5, 2, and 1, right? So, yes or no? So 2 is also going to have at least 1 root, because it's a polynomial. What about 3? Why not? So a couple of reasons. Yeah, this is a negative exponent, and it's not an integer either, right? Roots, even if it were, so let's do another scenario. What if it was just 3x to the root 7? No. Still no, because root 7 is not an integer, right? So 3 is no. And not because it's not a polynomial. Okay? Any questions on that? So whenever you're asked, does this function or does this equation have at least 1 root, all you have to look at is whether it's a polynomial or not. If it is, then it does. If it's not, then we don't know. Okay? No. Maybe Monday. You know what? Let's skip this example. We don't need to do it. Let's go straight to the linear factors theorem. Which, in a nutshell, says that any polynomial can be written in terms of linear factors that look like this. You'll have a lead coefficient and then you simply just write x minus a root times x minus another root times x minus another root, and so on. So any polynomial can be forcefully factored as long as we know what the roots are. This is not to say that everything factors nicely. We're just saying that if we happen to know what the roots of the equation are, then we can write it in this format. Okay. For example, let's write x squared minus 2x plus 4 in factored form using the linear factors theorem. So first, you would see if you can factor it the way you normally factor things, which in this case, can you? How? X minus 2 squared would give me x squared minus 4x plus 4. You cannot factor it. So what we're going to do is find the roots. How do you find the roots? Use the quadratic formula then. So we're going to do x equals opposite of b plus or minus the square root of 4 minus 4 times 1 times 4 all over 2 times 1. 4 minus, what is that? Minus 16, so square root of negative 12. And so that's 2 plus or minus?
2y.
How does 12 reduce? Square root of 12.
2y.
So 2 root 3 I over 2. Yeah, everything's divided by 2, so 1 plus or minus root 3i are the two roots. So now that we know what the roots are, we can say that x squared minus 2x plus 4, what's the lead coefficient? Here it's 1, so here it's 1. Okay, we can write it in or not. It doesn't matter if it's the 1. And then we do x minus, what's the first root? Just 1? So that's one of the factors. The other factor would be x minus the next root, which is 1 minus root 3i. Okay? Why is there what? Are you sure? So as long as you know the roots, for example, if the roots were 6 and 7, how would we write it? If the roots were 6 and 7, x minus 6, x minus 7. If the roots are a little funky looking like these, just do x minus, put parentheses around it, write in the root, and do the same thing with the other one.
So you're pretty much just making that like one term.
Yeah. Yes.
So for the lead thing, does that come from the first term?
Yes.
Okay.
So if this happened to be a 3, I would still do quadratic formula, find my roots, and then when I wrote it using linear factors theorem, I would just keep this number in front the same. That's a good question. Okay, so these are the kinds of questions you're going to see. Factoring things like that. In addition, I could also say work backwards and find actually, you know what? Let's review something first, which I think is going to make life a little easier. Let's review. Do you guys remember the rules between roots and quadratics?
No.
So for x squared plus bx plus c, do you remember what happened when we added the two roots together? It was a long time ago.
When did we learn this?
First term.
We learned this in this class.
Yeah.
I can't remember something else.
The sum of the roots is equal to the opposite of b, and the product of the roots is equal to c. I'm telling you this because it's going to make life easy. Okay? I will illustrate with an example, both ways. You can pick which way you want to do it. Okay? Find a cubic polynomial with roots -2, 3 minus root 2, and 3 plus root 2. What do we know about the polynomial if these are the roots? Do we know anything about it?
Can you do that form thingy?
What form thingy?
Linear.
The first one.
I don't know what you mean by first form thingy.
Let's see.
If -2 is a root, what do we know about the equation when you x plus 2 is a factor?
That's the form thingy.
That's what you're talking about. Okay.
What?
Oop.
There's a form that we just.
The linear factors form is what you're talking about, right?
That form.
That form. Okay. So if 3 minus root 2 is a root, then what else is a factor? X
Square.
minus 3 minus root 2. And if if 3 plus root 2 is a root, then what's the other factor? X minus 3 plus root 2. How would you do that?
We don't do that.
No, 'cause you just don't-
You have to eventually multiply this out, right? So now here's what I was going to say. If you remember these shortcuts up here, this makes your life a whole lot easier. Okay? I would start by multiplying these two out, which you can either do by hand and FOIL it out, or if you remember that the quadratic comes from these relationships, and you know what the roots are, right? Can you add these in your head? Like, what's 3 minus root 2 and then added with 3 plus root 2 going to be?
6.
R1 plus R2 is 6. Everybody see that? 3 plus 3 is 6. The negative root 2 and the positive root 2 cancel out when you add them up.
So it's pretty much
So what's 6 equal to?
Wait, why did I cancel out?
negative is equal to
3.
Oh, it's
Does that make sense? So then what's 6 equal to?
negative
Negative b. So what's b?
x squared minus
There we go.
and then you have to find c.
Could you multiply them out without doing too much effort?
Sure.
These are just conjugates, right?
Also the middle.
So the middle term's canceled. How nice is that? It's 9 minus root 2 times root 2, which is 2. So what's c?
7.
Yes.
Okay, so it's like R1 times R2 or plus whatever. But like, how do you know which one's 1 and which one's 2?
It doesn't make a difference. It's just, yes.
You could put it on the first and the last if you wanted to do
Yes, but it makes more sense to do it with conjugates. But it technically doesn't matter.
Okay,
Yes.
so like,
You could have done like this root and this root added together and to get a confusing looking polynomial and then multiplied it with the other one. Does that make sense? Okay. All I'm doing here, since these are, I'm calling this R1 and R2 because these are the ones that are goofy to FOIL out, okay? So now what you can do from here is actually multiply the normal way, because you know how to multiply this out, right?
Yeah.
So x times x squared is,
wait, why are you not
well, because we have to multiply it out and put it in that normal standard form.
Isn't that like the division?
Q or x cubed.
It's partly yes and no. We're just going all the way back to the beginning is what's going on. So x cubed minus 6x squared plus 7x plus 2x squared minus 12x plus 14. Combine your like terms. You get x cubed minus 4x squared minus 5x plus 14. That's your final answer. So this polynomial has these 3 roots. If you were to actually solve it or graph it and do what you had to do, you would get negative 2 as one of the roots, and then you'd get these imaginary roots, or I'm sorry, these other x-intercepts that are irrational. Okay? Now, what would the long way look like? You can write it down. If you're going to forget these relationships, here's what you would do. X minus 3 minus root 2 times x minus 3 plus root 2. I would still start with the last 2. And then what you would do is just FOIL. X times x is x squared. And then you do x times this. What's that? I'm just doing it where you actually multiply it all out so you can see that you get the same thing. And then you take x times this negative thing here. So I'm going to put minus x times 3 plus root 2. And then I'm going to do the same thing here. Another negative x with 3 minus root 2. A negative times a negative is positive. So I'm going to write this down. And then if you were to distribute everything, you get x squared minus 3x minus root 2x minus 3x plus root 2x. If you multiply these out, you get 9 minus 2. You guys see where this is going? What happens here?
I think it cancels.
The root 2's cancel. You get x squared minus 6x, but that's exactly what we had up here. Plus 7. And then the rest is the same.
So why would you do all that?
That's exactly my point.
Showing us
If you forget the rule, you're going to have to do it this way.
that's an ugly rule.
If you remember the rule, then you can do it this way.
But rules, what
Okay.
are we talking about? Like
couple more.
What software do you use to record?
ImageMate.
Yes.
Find a quadratic equation with zeros, 2 and negative 4, through the point 5, 6. Here's what we do. Do we know the lead coefficient? We do not. So I'm going to write it down as just A-N, A sub n. But we do know these two things, which are zeros, synonymous with x minus 2 and x plus 4. So we know that these are the factors. And now here's the easy way to do it. What's this represent? That's x. What does this represent? Y, which is the same as f of x. So if you just plug in the values, this is the same as saying 6 equals the lead coefficient, and then what's x? 5 minus 2, and then 5 plus 4. We get 6 times lead coefficient is equal to 3 times 9. So what's the lead coefficient if you solve for it? 6 over 27 is correct. And now, all you would do is then say f of x equals 6 over 27 times x minus 2 times x plus 4. And if you have to multiply it out, because maybe they want it in standard form, you know what to do from there. Okay. Farewell. Homework's day. Homework is the packet, which matches 13.3. It's like 6 or 7 questions.
Whoa.
Make sure you do them all, otherwise you'll have no chance on Monday.
Wait, is this part of it?
Yes.
Okay.